So this question says that two objects are projected vertically upward at different times with speed u1. So let's write that down. u1 is 80 meters per second and u2 is 100 meters per second respectively. The second projection occurs 2 seconds after the first. When and where, that is, at above the ground, will they meet? Taking g to be 9.8 meters per second square or g equal 10 meters per second square. All right. Now let's put visual to this. Let's try and picture what we are looking at. So we have two objects thrown at different times. The first one, which has initial velocity of 80, was thrown upward. Then after 2 seconds, so I'm going to take the time for the first one. Time for the first one, for the first object, t for the first object, I'm going to call it t. That means t for the second object is going to be t minus 2 because it was thrown 2 seconds after. So t for the first one is t. So time for the first one is t. Time for the second one will be t minus 2 because it delayed by 2 seconds. The motion has begun, so it delayed by 2 seconds. It will be t minus 2 seconds. All right. Now we are looking for where, when, and where. That is, we are looking for time and the position above the ground where they will meet. Now, how do we solve this? Since we are looking for time and we are looking for distance, so we have g, s is unknown. We have g to equal 9.8 or 10. I'm going to stick with 9.8 meters per second square. The equation of motion which you should use then should be s equals to ut plus half gt square. Now let's write the equation for each of them. Starting with the first object, I'm going to write it as s1 equal to u1 times t1 minus, because it's going upward against gravity, if you take downwards as negative, half times g times t1 square. That means s1 equal, u1 is 80, t1 is t, minus half times 9.8 is 4.90 square. So I'm going to write it as 4.90 square. Half times 9.8. That is 1 over 2 times 9.8 since g is 9.8. Now we cannot solve further. So I'll write this as equation 1. For the second object, let's write it as s2 equals to u2 t2 minus half g t2 squared. So s2 is equal to, u2 is 100. So 100 times t minus 2 minus half times 9.8 is 4.9 t minus 2 whole square. So we cannot solve further from here also. I'll write this as equation 2. Now, where and where would they meet means that their two distances must be the same. That is, s1 must equal to s2. So let's equate s1 and s2. That means we have 80t minus 4.9t squared is equal to 100 into t minus 2 minus 4.9 multiplied by t minus 2 all squared. So let's do our math carefully. 80t minus 4.9 t squared equals, let's fold this bracket. So we have 100t minus 200 multiplied by 4.9 into t minus 2 multiplied by t minus 2. I'm just doing it carefully so that you can understand. Or step by step. 4.9 t squared equals to 100t minus 200 minus, so we have 4.9, write it this way. So t minus 2 times t minus 2 is going to give us t squared minus 2t minus 2t plus 4. That is following this bracket. T times t is t squared. T times negative 2 is negative 2. Negative 2 times 6 is negative 2t. then negative 2 times negative 2 is 4. So we now have 80t minus 4.9t squared equals to 100t minus 200 minus, so we have 4.9 into t squared minus 2t is minus 4t plus 4. All right, so we have 80t minus 4.9t squared equals 100t minus 200 minus, let's fold this bracket now. 4.9 times t squared is 4.9 t squared. 4.9 times 4 equal minus 19.6 t. The 4.9 times 4 is plus 19.6. Going forward, we have 80t minus 4.9 t squared equal 100t minus 200. Negative times 4.9 t squared is minus 4.9 t squared. Negative times 19.6t is plus 19.6t. Negative times 19.66 minus 19.6. So let's see what we can cancel out. This can cancel this. Negative 4.9t squared can cancel 4.9t squared. So we are left with 80t equal 100t minus 200 plus 19.6t minus 19.6. Collecting similar terms, I'm going to have negative 100t subtract from both sides. So 100t taken to this side, we have 80t minus 100t, which is going to give us negative 20t equal negative 200 minus 19.6 should give us negative 219.6. Then we have plus 19.6t. Let me clear out some space so that we can continue on the left side. In continuation, I'm going to subtract 19.6 from both sides. So we have negative 20t minus 19.6t equal negative 219.6. So this should give negative 39.6t equal negative 219.6. Divide both sides by negative 39.6, negative 39.6. So negative cancel negative. T will be 219.6 over 39.6. So T will give us 5.55 seconds. So they are going to meet after 5.5 seconds. Then where would they meet? We can use our equation 1 that says that S1 equal 80t minus 4.9 t squared. If you can't see equation 1, you can go back, but this is my equation 1. So since they are meeting at the same distance, you can find S1 or S2. So S1 will be 80 times 5.5 minus 4.9 times 5.5 squared. So 80 times 5.5, 80 times 5.5. 80 times 5.5 will give 440 minus 4.9 times 5.5 squared will give 148.225. So the distance at where they will meet will be 440 minus 148.225. That should give 291.775 meters. So when they will meet, T will be after 5.5 seconds when the first ball is thrown, or they will meet after 5.5 minus 2, 3.5 seconds, or you can say they will meet after 3.5 seconds when the second ball was thrown, because the second ball was thrown after 2 seconds. And where they will meet, the distance where they will meet, S, is equal to 291.775 meters.